Hi, this is Ms. Dabnick, and today we're going to be multiplying polynomials. A polynomial basically is variables separated by an addition sign. So you have a term and a term here, so this would be called a polynomial, or more specifically a binomial. And again, you have a term here and a term here separated by an addition sign, so this would be called a polynomial, otherwise known as a binomial because of the two terms. So to start off with, before we do our main example, we're going to break this up into a binomial times a binomial. So with just regular numbers. 57 can be thought of as 50 plus 7, and 48 can be thought of as 40 plus 8. And I'm going to find the area of this rectangle by using length times width and our binomials. So when I divide up the 57, I have 50 here and a plus 7 here. And then the 48 could be a 40 plus an 8. So then I'm basically doing 4 separate area problems inside my rectangle. 50 times 40 is 2,000. 50 times 8 is 400. 7 times 40 is 280, and 8 times 7 is 56. So then when I add up the inside, I should get that my area is 2,000, let's see here, 736. All right. So what I did here was I gave the 50, multiplied it to the 40, and I took the 50 and I multiplied it to the 8. And then I took the 7, multiplied it to the 40, and the 7 and multiplied it to the 8 to get the 56. All right, so what happens when you have an example where you do not know that first number, you actually just know that it's a variable called x? Well, I'm going to use my product map and algebra tiles to set up this problem to find out what the area equals. Remember, length times width equals area. And that's what we want to know. What is the area of x plus 3 times x plus 2? All right, so to set up my product map, I pulled out a rectangle and 3 1 pieces, and then another rectangle and 2 1 pieces. And I need to find the area, so these are my dimensions, and I'm interested in knowing the insides. X times x is x squared. X times 2 is 2x. X times 3 is 3x. And 3 times 2 is 6 1 pieces. Now this has to be a complete rectangle or square. We can't have this side here missing because then it wouldn't be the actual area. So the area is everything on the inside, so I can take off the dimensions. That helped me get to the answer. So there you go. And now I can see that my area is x squared plus 5x's plus 6 1 pieces. All right, let's just sketch that into our notebook. We have, again, x plus 2 and x plus 3. Here's our x squared piece, and then our 3x's. 2 more x's here, and these are all 1 pieces. So when you combine your like terms, you have x squared plus 5x's plus 6, and that's your answer. Now, I just want to point out that what you're doing is 2 separate distribution problems. So when you do x times x plus 3, you are basically splitting up this x plus 2. You're giving the x to the x plus 3, and then you're going to give this 2 right here, this 2 to the x plus 3. So x is given to the x plus 3, and the 2 is given to the x plus 3. It's 2 separate distribution property problems. All right, let's see if you can do example C. Please pause here. All right, those of you who unpaused, let's check our work. X minus 1, and then you have x plus 1, 2, 3, and 4. X times x is x squared. X times 4 is 4x's. 1, 2, 3, 4. x times negative 1 is a negative 1x, and then negative 1 times 4, these are all negatives. So remember, when we have negatives, we show that they're negative by shading them in. Now, to find the area of these two binomials when I multiply them, I have to combine my like terms. So my area is going to be x squared plus 4x minus 1x minus 4. So I can combine the like terms here, and my answer is x squared plus 3x minus 4. All right, example D, we're going to find the length times the width for these already set up problems. You should pause here to make sure you got it correct. Length times width equals area. So I know that this length is x plus 3, and this one is also x plus 3. My area, I just need to combine my like terms. So I have an x squared, 6 x's, and then 9 one pieces. All right, number 2, we have x times the quantity of x plus 1, 2, 3, 4. So this length is x, and this width is x plus 4. My area, or the insides, are x squared plus 4x's. Now you should notice that all I did really is use the distributive property, but just one time instead of 2 times like in these problems right here. All right, so this one is x plus 1 and x plus 6. So I did x times x plus 6 right here, and then the plus 1 times x plus 6 down here. So when you combine your like terms, you have an x squared, you have 7 x's, and you have 6 one pieces. All right, that's it for multiplying binomials. Good luck.